When we decide to make a change in our life, say to exercise more or to quit smoking, why do some of us succeed while others don't? Wouldn't it be great if we had a crystal ball that could help us predict whether or not we will succeed? At the Institute for Social Research, Assistant Professor Emily Falk is getting closer to finding that crystal ball in the form of a functional magnetic resonance imaging, or fMRI machine. John Lofi has the story.
How can measuring a person's brain activity actually help predict future behavior change? I visited Emily Falk, director of U of M's Communication Neuroscience Laboratory, the only one of its kind in the country, to ask her about her groundbreaking research. You do all this research about how the messages that people hear from the media and other places affect their behavior. Tell me a little bit about how that works and what kind of research you're doing there.
We know that the media have somewhat profound effects on people's attitudes and behaviors, but we also know that people don't necessarily notice when they're being affected by these kinds of inputs.
Falk began her line of research when she was a graduate student at UCLA.
Initially, when we started doing this work, one question was, can we get any kind of information out of the brain that we're not getting from typical self-report measures? So if I just ask you, what are you going to do? Can I actually get more information by looking at your brain at all, or is it giving me the same information? So one of the most exciting things from the past couple of years has been that we're able to extract this information that we're not getting from other data sources. We can explain a lot more about how people behave than they themselves are telling us.
Dr. Falk really combines social cognitive neuroscience with studies of persuasive communication. And this has really never been done before she started doing this. What she has done is taken this new technology of functional magnetic resonance imagery and used that to actually be able to predict when people are persuaded by communications and when people are not. Not based on their self-reports, but based on what's going on inside their brain.
When we look at neural activity in the medial prefrontal cortex, what we found is that when we see increases in this brain region in response to different kinds of messages, different kinds of media, for example, that tends to predict people changing their behavior in a way that's consistent with the message. Whereas when we see lower levels of activity in that region in response to the messages, that tends to predict people not behaving in a way that's consistent with the message.
And where are these messages coming from? I mean, is this like you measure somebody's brain while they're looking at the warning label on a tobacco package or on a TV commercial, or how does that work?
There's a range of different kinds of stimuli that we'll use. So there's a little bit of a trade-off between having very controlled stimuli where we manipulate the exact characteristics, and then having the kinds of things that people actually see, like on TV or hear on the radio. And so we try and do both.
For those who want to quit smoking, and for those who need them to.
You can also test different messages and see which messages are actually end up being most compelling, which could provide great advances in public service announcements, because it'd be easier to know ahead of time whether a particular announcement will work or not work in changing the way people behave.
In upcoming work, we're really interested in the fact that FDA is moving to put warning labels on tobacco packaging. And so one question is, what messages are going to be the most effective? The line of research started with simple health behaviors like sunscreen use. We extended it to tobacco use. And now we want to see whether it also extends to other motivationally relevant, important health behaviors. So for example, can we help people increase physical activity? Can we do more with the tobacco? Can we broaden the scope of what we're doing to include other health behaviors?
Her research has so many potential applications that Falk is affiliated or collaborates with at least 8 different departments, schools, and centers at U of M alone. It's at the Transportation Research Institute, where graduate student Joshua Karp is working with Falk to learn more about the teenage brain. Josh, you work with one of the most scorned groups of people in the entire world, teenage drivers. Tell me about the study that you do with them.
Well, basically, as won't surprise anybody, teenage drivers are scary on the road. They're the group of drivers that get into the most accidents and take the most risks. And so the basic question that we're trying to ask is, why do they do it, and how in the future can we stop them from doing it? So we're going to actually measure their behavior in a situation a lot like real life in a driving simulator. So they're going to get into an old 85 Buick with all the parts taken out, no engine of course, and they're going to see projected on screens in front of them, on the sides and behind them, what looks like a video game. They're going to drive around the simulated environment, and we're going to see how safe their driving is. Are they going to do things that would scare you if they were driving in real life? Here's the new part. A week before they get into the simulator, we're going to bring them in for a separate session at this fMRI machine. So that's functional magnetic resonance imaging. That's a method that we use to track what the brain's doing in real time as people are thinking and doing simple tasks in the scanner. So we're going to put them through a couple of tasks that measure their propensity for taking risks, how much they enjoy risk-taking, how they interact with other people socially. And we're going to see if by measuring properties of their brain during simple, rather boring tasks, we can predict which of them are going to be driving safely or less safely in a simulator a week later.
When I was taking driver's ed, we got the scare film, right, where we saw all the terrible, terrible things that happen in these crashes, and I don't know that that actually made me a better driver. But I think what you're saying is if you could test that and find out if that's kind of thing is likely to make teenagers better drivers. Is that what you're getting at?
Yeah, that's right. So one way to think about this is we want to figure out what's going on in the minds of teenagers that make them scary drivers. And if we can get some insight through this basic science perspective into what's going on in their heads, we can design interventions that work better for driver's ed than showing them a terrifying film, which we know from other research might just turn people off.
When you're doing all this collaboration across different fields at the university, do you find that people's different perspectives from, say, transportation to cancer, does that fire off new ideas that you probably wouldn't have come up with other ways?
Oh yeah, it's super exciting because it means that you can attack problems that there's no way you could address by yourself.
We combine experts in computer science, statistics, public health, psychology, basically you name it. And none of this would work without all of those different people with their own perspectives making these projects a success.
Falk is continuing to extend her research, creating neural focus groups and exploring new concepts such as the neuroscience of buzz.
There seems to be a distinct neural signature in response to ideas that are destined to spread. And one of the things I'm most excited about right now is taking a step back and sort of putting the pieces together. So connecting what's going on in individual brains to how those individual brains are behaving in the real world, and then what that means for the real world.
Falk's hope is that it means a happier, healthier, and safer world as a result of her research.